Hey gang, today I know we didn't really have much of a chance to finish the lecture on lines of best fit. There were some other key concepts here like determine and interpret the correlation coefficient. So I want to take a moment to go ahead and do this. And I've asked the substitute to pull up the files, these same files that we were working on, so you can go through and get the notes. So of course, these definitions, I do want you to get them. You don't need to copy them down exactly, but more importantly is to have the language. And so again, those we can pull those up in a moment. But Jared mentioned something the other day, and I want to take a moment to go through these two slides right here, and then I'll show you how to do the regression. We'll walk through an example, and then you can do it. So when we think of squaring the residuals, positive and negative values cancel out. So what we're always doing, whether you overpredict or you underpredict, by squaring those results, it eliminates any of the positive or negativeness of it. And what ends up happening is it just means you're off. So if you overpredict, you're off. If you underpredict, you're off. Squaring it eliminates those values canceling out. So that's why when we went through this example here, we squared these values because, again, these values, if we didn't square them, would have canceled out. Because you square them, this becomes 1, and this becomes 1, and when you add them together, it becomes 2. It means you have an error of 2. So that's the big concept there. The other thing we didn't talk about, and please write this down, again, we can pull the slide up in a moment, is an R value is the correlation coefficient, and that means it's a value between positive 1 and negative 1. And when it's very close to positive 1, it's very strongly positively correlated, positive correlation. When it's negative 1, it is very strongly negative correlated. And when it's 0, there's no correlation. So most things have a value, well, all regressions have a value between positive 1 and negative 1. But the closer it is to positive or negative 1, the better fit it truly is. So again, you can pull the slide up after this short little video is over. What we did was this slide here, and again, I highly recommend that you pause a moment because these are the steps in order to enter data on the calculators. And what you need to do is, first of all, hit, and I'm going to try to do this in such a way that you can see it. I don't know if you can see it. Yeah, no, I don't know how to do it. You're going to hit second, data, and you go over, where am I? Hey, get back here. That's so hard. And you clear the data. Then you hit second, data again, and make sure that you're on 2 variables, right? You have an X and a Y. Hit enter. Then, when you hit the data button, you can enter the X values and the Y values. And that's what we did in this problem here. We said, okay, my X values were 5, down arrow, the Y value was 0, down arrow. The next one was 6, and 6 went with negative 1. I'm doing my best. All right, hang in there. And then again, 6.5, 3, 7.5, negative 2, and then of course 9 and 4. And then last but not least, once you hit enter on that last one, you hit stat var. And actually in statistics we use this a lot. N is the number of entries you had 5, and you scroll over. Wow, I can actually watch this. And I go over, and the last 3 are the ones we really want. Oh, I went too far. I didn't know that was possible. Then the last 3. A, B, and R, where A is the slope, also known as M. I don't know why they don't just call it M. B is the intercept, U, and R is the correlation coefficient. And if you use that information, it is really helpful. And you can test any one of these points to see how well it predicts. So if I plug in if you plug in any of these x coordinates into this equation, you'll get a y coordinate out. So just for kicks, let me do this here for a second. You might find this interesting, and then I'll stop, and then you can go on to your problems. So based on this, A, the slope was 0.78. B, the y-intercept, negative 4.53. I'm going to plug 5 in here. So 5 times 0.78. Actually, I was holding it on A, so I did A times 5 minus 4.53. And then I hit enter. Look at that, negative 0.6. So it's not exactly 0. It's close to 0. It's a little bit too low. It's a little bit, under-predicted, right? And that's how this works. So now when I answer these questions, what is the correlation coefficient? Well, the correlation coefficient, when I go back to my var here, is 0.46. So you can write that in. And then how well does this line represent the data? Not very well. 0.46 is not very close to 1 when you're talking about from 0 to 1 or 0 to negative 1. Describe the correlation. Well, 0.46 is still positive, but it's a weak positive correlation. That's the idea. There's a lot of videos. Khan Academy has a lot of videos on this too. What I want you to do then is try these problems, and again, do it with your neighbor. Make sure you're getting similar results. You know how to do it. And the solutions and whatnot are posted in the smartboard file on the thumb drive so you can get to them. Have a great day.